Okay, here we are getting ready for part 2 of our chapter 3 test. And before we go ahead and get started with that, let's remember a couple of the things that you are going to need to know for your test. First of all, obviously we need to know the quadratic formula. And our quadratic formula is x equals, so we're finding our x values, the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. And the first thing we're going to be asked to do is to find the discriminant. And if you remember, the discriminant is just the value that you get underneath of the radical. So when we identify our a, identify our b, and identify our c, we just plug those numbers in. Oops. And just to remember also, that value of our discriminant, okay, that's the discriminant. The value of that, if it is positive, that number underneath of the square root is positive, that means there are 2 real solutions. If it is negative, that means there are 2 imaginary solutions. And if it is 0, that means there is 1 real solution. Okay, so first thing it asks us to do is to find the discriminant and how many solutions there are in the type of the solutions. Always, the first thing that we want to do is to make sure that we get it set equal to 0. I always like to have my a value, my lead coefficient, positive. So in this case, I am going to subtract 3x from both sides, and I'm going to add 8 to both sides. That's going to give me 5x squared minus 3x plus 8 equals 0. Now, I just need to identify my a, my b, and my c. A equals 5, b equals negative 3, and c equals 8. So my discriminant is that value underneath of the square root, which is b squared minus 4ac. In this case, b is negative 3, so I'd have negative 3 squared minus 4 times 5 times 8. Negative 3 squared is 9. And then here I have negative 4 times 5 is negative 20. Negative 20 times 8 is negative 60, so I'd have 9 minus 160, which is 151. Since that is negative, that tells me that I am going to have 2 imaginary solutions. Okay, so 2 imaginary solutions is how many in the type, and my discriminant is negative 151. Okay, same thing on this one. It's just going to be the same idea. I'm going to add 15x to both sides, so I end up at 0 equals x squared plus 15x plus 36. A equals 1, b equals 15, c equals 36. So when I put that into my b squared minus 4ac, I get b squared is 225 minus 4 times 1 times 36, which is 225 minus 144, which equals 81. So my discriminant is positive 81, which tells me there are 2 real solutions. This time we're actually going to solve all the way out using the quadratic formula. So I have x squared plus 6x plus 15. Again, it might help every time if you want to write that quadratic formula down. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals that. And identify what our a is. A is 1, b is 6, c is 15. Okay, so then I'm just going to plug my values in. I have x equals the opposite of b, so I'm going to have negative 6 plus or minus the square root of b squared. Well, b squared is 6 squared, so that's 36 minus 4 times a times c all over 2. Okay, and I'm going to keep moving. I have negative 6 plus or minus. Underneath the radical, I have negative 4 times 1 is negative 4. Negative 4 times 15 is negative 60. So I would have 36 minus 60 under the radical all over 2. So then I would have x equals negative 6 plus or minus the square root of negative 24 over 2. It is very important to note that you cannot simplify this by taking a 2 out of everything right now. The negative 24 is under the radical, and you cannot simplify things under the radical with things that are not. So that 2 in the denominator cannot go into that negative 24 and call it negative 12. If you're going to simplify, it has to be the coefficient out in front of the square root that you can simplify it with. So then we need to think, all right, I've got a square root that's negative, so I know I can take out an I, and then I need to think factor pair of 24. I'd have the square root of 4 and the square root of 6. So that's going to simplify to negative 6 plus or minus, okay, the square root of 4 is 2 times I times the square root of 6, all of that over 2. Now, if you want, you notice that you can take out a 2 out of both of the terms, which means you could have it be, x equals negative 3, because negative 6 divided by 2 is negative 3, plus or minus I times the square root of 6. That is your most simplified answer. Okay, we're going to use the quadratic formula again here. And on this one, we again need to just make sure it's set equal to 0. So I'm going to add 3x to both sides. And I get 0 equals 2x squared plus 3x minus 4. Again, we have our formula, and we need to identify our a, our b, and our c. A is 2, b is 3, c is negative 4. So when we plug it into our formula, the opposite of b is negative 3 plus or minus the square root of b squared, 3 squared is 9, minus 4ac. All of that over 2a, which is 4. 2 times 2 is 4. Okay, so you need to be a little bit careful in here underneath of the square root, because when we did this in class, a lot of kids got a little bit confused underneath of the radical. You have 9 minus 4 times 2 times negative 4. So if we're going to think about that, okay, negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. So we are actually going to have 9 plus 32 underneath of our radical divided by 4, which is negative 3 plus or minus the square root of 41 over 4. Since the square root of 41 does not have any perfect square that's a factor, we can be done. This time we are going to do substitution and elimination, and just a reminder about how substitution and elimination works. First of all, it's a system, which means, let's go up over here just a little bit, which means that you have 3 possibilities. You have a parabola and a line. You have a quadratic on top. You have a linear equation on the bottom. So if you have this parabola and a line, it could have 2 solutions that look something like that, in which case you'll have 2 values of x you have to substitute back in. It could have 1 solution, look like that, which means there'd only be 1 value of x you're substituting back in. Or there could have no solution, which would look something like that, which means that they never intersect. In this case right here, when you have a system that never intersects, that means you get a negative underneath of the radical. And that's the case with a system of equations. If you have an imaginary solution, that means there's no solution for the system. That means they never intersect. So if we come back here and I look at this and I decide I want to use elimination because I see I have a negative y and a positive y, so my y's are going to cancel. So if I do that, I just add vertically, and I get 2x squared minus 4x. My y's are gone because negative x, positive x, equals negative 2. Now all I have left is x's, and it's a quadratic, so I need to get it set equal to 0. So I'm going to add 2 to both sides, and I get 2x squared minus 4x plus 2 equals 0. Anytime I have a coefficient, a lead coefficient that's not 1, I look see if I can take out a greatest common factor. In this case, I can take out a 2, and I'm left with x squared minus 2x plus 1. Don't forget that when you divide 2 divided by 2, that's 1. They don't just cancel out. Equals 0. And now we just factor, and I'm thinking, what are two numbers that multiply together to be 1 and add together to be negative 2? So in this case, I would have x and x minus 1 equals 0, which means my only x value is x equals 1. This is not where we are done. That just is the x value of our ordered pair. Now, I need to go back up to one of my original equations and substitute 1 in so I can figure out the y value. In this case, it'd be easiest to use my linear equation. So I'm going to go and substitute back into negative x plus y equals 3. So I would have negative 1 plus y equals 3. It's negative 1 because x is 1 and the equation says negative x. So if I add 1 to both sides, I get y equals 3. So my ordered pair, y equals 4. So my ordered pair, where that line and parabola cross, is at the ordered pair 1, 4. Don't forget, when you're doing systems, you have to substitute back in to get the ordered pairs. All right, substitution or elimination. Again, I am going to use elimination because, again, I have a negative y and a positive y. When I add vertically, I get negative 6x squared equals, my x's here are also going to cancel, equals 4. All I have is an x squared, so I'm going to solve with square roots. I'm going to divide by negative 6 and get x squared equals negative 4/6. When I take the square root, I have a negative underneath of the square root. If I have a negative underneath of the square root, that means I'm going to have two parabolas that never intersect, which means there is no solution. All right, one more substitution or elimination. In this case, I would use substitution because they are both already set equal to y, which means I can just set them equal to each other. So I know that if y equals negative 3x squared minus 30x minus 76, anywhere I see a y, I can take that out and put that in its place. So I'm going to have negative 3x squared minus 30x minus 76 equals 2x squared plus 20x plus 44. Okay, so now it's just x squareds and x's, so I need to get it set equal to 0. I want to have a lead coefficient that's positive, so I'm going to move everything to the right. So I'm going to add 3x squared to both sides. I'm going to add 30x to both sides. And I'm going to add 76 to both sides, which leaves me with 0 equals 5x squared plus 50x plus 120. Now I just have a quadratic. First thing I look for is, can I take out a greatest common factor? In this case, I can take a 5 out of everything. So I get 0 equals x squared plus 10x plus 24. 120 divided by 5 is 24. Okay, so then I'm thinking, is there a factor pair of 24? They multiply together to be 24, add together to be 10. In this case, it would be 6 and 4. So I would have x and x plus 6 plus 4 which means the two places where it crosses are at x equals -6 and x equals -4. Remember, we started with two equations, which means that these two parabolas are going to cross at 2 points. So we have the x values for those 2 points. We need to find the y values, which means we need to go back and substitute -6 in for x to figure out your y, and then substitute -4 in for x to figure out y. So I'm going to go back. I'm going to use my bottom equation, my 2x squared plus 20x plus 44, just because everything's positive. And I'm going to say y equals 2. I'm going to take out x and put -6 in its place. -6 squared is 36 plus 20 times -6 minus 76. Okay, so that's me just taking out x and putting -6 in its place in that equation. So I get y equals 72 minus 120 minus 76. Okay. Aha, I see what I did wrong. This here is not minus 76. I copied from the wrong problem. So we notice up in that problem it was plus 44, not minus 76. It was plus 44. So I wrote down this should be plus 44 here. There we go. That looks a little bit better, which means 72 minus 120 plus 44 would equal -4. So my first ordered pair is -6, -4. That's the first place that it crosses. Now I'm going to do the exact same thing, except I'm going to take out x and I'm going to put in -4. So I'm going to have y equals 2 x squared, -4 squared is 16, plus 20 times -4 plus 44. So I get y equals 32 minus 80 plus 44, which gives me y equals -4. So my second ordered pair is at -4, -4. These take a little bit of time when you have two solutions, but you have to actually go back and substitute your work in to show how you got both of your ordered pairs. Okay, so now we are getting into the shading part. Okay, so you have a graph here. Our ordered pair that we always like to pick is the ordered pair 0, 0. Okay, so if I am checking for 0, 0, 0, 0 is on the inside. Okay, and I'm going to take out x and I'm going to take out y and I'm going to put 0 in its place, and I get 0 is less than -4. That is false. 0 is not less than -4, which means if it is false, we're going to shade the opposite of where it's at. So I'm going to shade the outside of my parabola. Okay, on this one I have y is greater than or equal to x squared plus 2. That's the red one. And I have y is less than or equal to -2x squared plus 3x plus 5. So if I'm looking first at my top equation here, I'm going to check 0, 0. Okay, in red, the 0, 0 is on the outside. Okay, I'm looking at my red graph right now. The point 0, 0 is on the outside of the red. Okay, which means if I put 0 in for that, 0 is greater than or equal to 2. Is 0 greater than or equal to 2? That is false. Since it is false, I'm not shading the outside, I'm going to shade the inside. So the inside of the red is that part right there. So I'm going to shade the whole thing. Okay, and then in blue, I'm going to do the same thing. The point 0, 0, erase this little guy right here. The point 0, 0 in blue 0, 0 is on the inside of the blue graph. Okay, it's on the inside, so when we put 0, 0 in, I get 0 is greater than or equal to 2, which is false, which means I'm not going to shade the inside, I'm going to shade the outside. So I'm going to shade the outside. Oh, wait just a second, I see what I did wrong here. I'm not shading the outside. Let me get rid of the blue right here, because if you noticed, I put the wrong inequality symbol in there. So just one quick second, let me shade my red back in. That was fine. My red is okay. However, if you notice right here, I put the wrong inequality symbol. I should have put less than and I put greater than. So let's fix that really quick. That should have been, that should have been less than, not greater than. So that should have been less than or equal to. And 0 is less than or equal to 2. So that is true. So this should have been true, which means since it's true, we should shade the inside. Sorry about that. Which means we would shade the inside. And the part that is the solution is where it overlaps, which is this kind of area right in here. So we need to make sure that when we are all done, that part is shaded in the darkest. There, this part right there. Okay, last couple of things here is graphing it on a number line. First thing that we need to do is find our critical points. That's just finding our zeros and plot them on the graph on the number line. All right, so if we look, x squared plus 4x minus 5, need something that multiplies together to be negative 5, adds together to be positive 4. So I'm going to have x minus 5 and x plus 1, which means my two critical points are at 5 and negative 1. So if I got negative 1, 0, 1, 2, 3, 4, 5. And they are going to be open dots at negative 1 and negative 5. Then I just need to test and see if I'm going to shade in between the 2 points or on the outside of the points. Well, if you notice, 0 is in between, so we're going to test the point 0. We're going to put 0 in, which can be 0, those are going to 0 out, and we just get negative 5 is less than 0, which is true, which means we're going to shade where 0 is at, and 0 is in between, so we're going to shade in between. Okay, last one. All right, so we have 4x squared minus 8x is greater than negative 3. Okay, first things first, let's get it set equal to 0. So we would have 4x squared. We'd have 4x squared minus 8x plus 3. We're just going to set it equal to 0 for right now, so we can factor it. Well, there's no greatest common factor we can take out, so I'm going to try the AC method. So I'm going to have my x over here. I need it to multiply together to be 12, add together to be negative 8. It needs to be multiply to be a positive, add together to be a negative, which means both of my signs need to be negative. So I'd have 1 and 12, or 2 and 6, or 3 and 4. 2 and negative 2 and negative 6 are going to get me negative 8. So I'm going to break negative 8 apart. So I'd have 4x squared minus 6x minus 2x plus 3 equals 0. Okay, so then I'm just going to factor by grouping. I'm going to take out a 2x here, and I'm left with 2x minus 3. And then on my second one, I'm going to take out a negative 1, and I'm left with 2x minus 3. So my two factors are 2x minus 1 and 2x minus 3. So my two critical points are x equals a half and x equals 3/2. So when I plot that on my number line here, I'm going to be at, here's 0, 1, 2, 3. I'm going to have 1 point at 1/2, which is going to be about here. So I'm going to have an open dot at a half. I'm going to have an open dot at 1.5. Okay, so that's 3/2 is just 1.5. Now I need to figure out where I'm going to test. Put my number line a little longer here. I'm going to test at 0. Okay, so if x equals 0, that means 0 is on the outside. It is not in between, it's on the outside. So when we put 0 in, okay, if we come up here to our one that we had, hang on, after we added 3 to both sides, we had 4x squared minus 8x plus 3 is greater than 0. If we put 0 in, that gets rid of those, and we have 3 is greater than 0, which is a true statement. If it is true, we shade where 0 is at, so we're going to shade on the outside. So we are going to shade the outside part of our number line. And good luck. If you have any other questions, just let me know. You can send me an email, or we can talk after school after you take the first half of the test. So see you tomorrow.